Welcome to my lesson on center of gravity. Let's start with an exact definition, or fairly exact. When we're talking about the center of gravity of an object, it's defined as the point around which a structure's weight is equally balanced in all directions. So let's keep going. Line-segmented objects have their center of gravity directly above the base of a support, and sometimes the center of gravity can be found outside a structure. So let's look at a teeter-totter. The little smiley face shows you where the balancing point is, which we would call the center of gravity. So if we moved this guy over here, what would happen to the teeter-totter? It would fall over this way. So the balancing point is another way of thinking about center of gravity, the balancing point. So let's keep looking at that. Here are some two-dimensional objects, and so in a square the center of gravity would be located right there, right smack dab in the middle. However, some objects like this one, the center of gravity, which is the imaginary point at which it's balanced, all the different weights are balanced, would be outside of the structure, and same with this. So let's talk about a technique you can use to find the center of gravity. So here's our imaginary structure. Step one, you divide the structure in half this way. So you make a line so that the two sides are on either way. Then you ask yourself, is the right side a mirror image or symmetrical to the left? Are they identical? If the answer is yes, there's equal amount on this side and this side, then you know that your center of gravity is somewhere along this line. Step two, you divide your structure in half this way. And again, now you ask, is the top the same as the bottom? So here's the top, here's the bottom. Are they identical? And so keep in mind, I'm not very good at drawing. So yes, they are. And so that would mean that your center of gravity is directly in the middle, right there between the two lines. Let's try this again. Let's look at the triangle. You draw a line dividing it in half like that. Is the left side symmetrical to the right side? This side symmetrical to that side? Yes, so we know it's above or below, or that it's on the line. You divide it in half this way now. Is the top the same as the bottom? No, this time it's not. There's more mass below the line, and so we know that the center of gravity is somewhere just below. We would say the center of gravity would be right about there for that structure. Let's look at this one to find out why the center of gravity for this structure would be outside of the realm, right there. So step one, go along the base and divide it in half right there. And is the right side the same as the left side? No, it's not. There's more stuff on the left. So we know the center of gravity is somewhere to the left of this line because there's more mass over here. Next, take this, divide it in half this way. Is there more mass above or below the line? So to the top or to the bottom? There's more mass below the line, so we'd say the center of gravity would be right about there. Let's try this one. Divide the structure in half this way. Is the right side the same as the left side? Are they mirror images or symmetrical? Yes, they are. So we know the center of gravity is somewhere along this line. Let's divide it in half this way. Is the top the same as the bottom? The top the same as the bottom? No, they're not. There's more below the line, and so the center of gravity would be somewhere below the line. Right about there would be the center of gravity. Here's why the center of gravity is so important. The center of gravity helps us to tell whether a structure is stable or not. So here's our block, here's the center of gravity. It stays on the desk provided that there is something underneath it to hold it up. But as soon as the center of gravity has nothing below its base, it becomes unstable and it falls over. So at this point in the picture, it's unstable. So watch what we could do. We could put a counterweight over here, and that would move the center of gravity now over here where this red dot is, which is why now the book stays on the table. Here's a good picture to show you how the center of gravity or balancing point is important. The center of gravity of this painting palette would be right there, and if we put our finger underneath the center of gravity, then it stays up. If the center of gravity is not underneath the balancing point, then the structure falls over. Let's talk about center of gravity in the human body. If you stand still, the center of gravity is located in the abdominal cavity, about 6 inches above your hip bones. So if you look at these three people, we can see that the center of gravity for the little baby's there. For the women, it's down lower, and for this man, it's a little bit higher above the belly button. For this diver, notice how now when he's leaning over, the center of gravity is tilted over just slightly. So when you change your position, so does the center of gravity because you've adjusted your weight. Let's talk about stability. So stability and balance can be easier if you're a larger mass. If the base is larger, because that makes the center of gravity lower, as long as the center of gravity is above the waist. And so let's move along. Whoops, a little too far, sorry. And let's get to the slide I want to get to right here. These are kind of neat little tricks about understanding the center of gravity. So if we look at this picture, this whole balancing trick has to do with understanding the center of gravity. And so we're going to try something like this in class. And same with this horse. It looks like everything's over here with this horse, but this counterweight is quite huge, causing the center of gravity to be shifted. Stability means a low center of gravity. The wider the base in the picture, the lower the center of gravity. For example, let's use our little trick with the Eiffel Tower. Let's get our pen out. Let's divide the Eiffel Tower in half this way. Is the right and left side the same when we cut it in half this way? Yeah, so we know the center of gravity is somewhere along the line. Let's go halfway up. Is the center of gravity from the top and bottom of this halfway line the same? No, there's more mass below because of the wide base, and so the center of gravity would be somewhere right there. Same with this tower here. So if we have strong bases, then we make stable structures. Strong, wide bases in building help make good, stable towers. So remember that in our activity.